Hello students, I welcome you all to my YouTube channel Ritika Chemistry Classes. So write down, the today's topic is Schrodinger wave equation. Our today's topic is Schrodinger wave equation. So what is Schrodinger wave equation? According to de Broglie's concept of dual nature of matter, all material particles possess dual nature. That is, they also behave like a wave and as well as particle. So Erwin Schrodinger in 1926, write down, Erwin Schrodinger in 1926, he described a wave equation that describes the behavior of electrons in an atoms or molecules. So Erwin Schrodinger gave an equation that will show the behavior of electrons. So in today's topic we will derive that equation, and this equation is known as Schrodinger wave equation after his name. So we will derive this equation. In order to derive this equation, let us consider a simple wave like that of a stretched string, and let y, write down, y be the amplitude of the wave, at any position x and time t, right? So the equation for wave motion will be given by, write down, the equation for wave motion will be given by del square y upon del x square equals to 1 upon u square del square y upon del t square. Here you can see that this is x square. Here you can see that we have partial derivatives with respect to y. So partial derivatives with respect to x and time. So in this we have double derivative of y with respect to x. And why this partial derivative? Because we know that this amplitude y, it will be a function of two variables x and t. So that's why we have taken here partial derivatives. And what is u? U is the velocity of the wave. U is the velocity, write down, with which the wave is traveling. You can also represent this velocity by v, but in order to avoid confusion with frequency, I will denote this velocity by u, right? So now this y, you know, it will depend upon two functions. It will be a function of two variables, x and t. So let us suppose that y is equals to f of x and g of t, right? Okay. So in order to solve this equation, we need to separate variables. That's why we have written y, it is a function of f of x and g of t, where f of x, it will be a function of x coordinate only, and g of t, it will be a function of time only. We are representing this equation as equation number 1, right now, and this is equation number 2, right? Now for standing waves, in case of standing waves, as you know that we are eventually we are deriving this equation for electrons, and you know I have already explained in the previous lecture that these electrons produce standing wave patterns, and the waves are known as standing waves or stationary waves. So for standing waves, this function g of t, it is equals to a sine 2 pi nu into t. In case of standing waves, this function g of t is equals to a sine 2 pi nu into t, where nu is the frequency and a is a constant known as maximum amplitude. A is constant known as maximum amplitude. Now we are going to substitute this value of gt in equation number 2. Write down. Substitute the value of gt, g of t, in equation number 2. Right? We are going to substitute this value of gt in from equation 3 in equation 2. What we will get, y becomes equals to f of x into a sine 2 pi nu into t, right? And you can see from equation 1 that we need the double derivative of y with respect to x and double derivative of y with respect to t. So we will do its double derivative with respect to t and x. So firstly, write down differentiating it with respect to t. With respect to t. What we will get, curly y upon curly t equals to f of x. Now x is a function of x only, so it will remain as it is. A is also constant, and you know the derivative of sine is cos. So it will be cos of 2 pi nu into t into this constant 2 pi nu. Because you know the derivative of sine ax is equals to sine का क्या होगा cos ax into this constant, this a, right? So but we need its double derivative, so again differentiate it with respect to t. You will get del square y upon del t square equals to, now again f of x will remain as it is, a. Now this 2 pi nu is also constant, so I am writing this 2 pi nu here, right? And the derivative of cos is minus sine, so you will get one negative here, minus sine 2 pi nu into t, because the derivative of cos is minus sine, and again you will get this constant 2 pi nu. So you will get minus f of x into a sine, or you can write 2 pi nu square, one second. Write 2 pi nu in the front, 2 pi nu whole square, right, into f of x, this f of x into a sine 2 pi nu into t. Right? And it will become 4 pi square mu square f of x. What is this a sine 2 pi mu into t? As you can see from equation 3, this is gt. So it will become f of x into gt from equation 3. Right? So this is our del square y upon del t square. Let denote this equation by this by 4 and this by equation number 5. Now differentiate equation 4 with respect to x. Right? Now if we differentiate this equation with respect to x, then you can see that this quantity depends upon time, but here we are differentiating it with respect to x. Sorry. So it will remain as it is. So differentiating equation 4 with respect to x, you will get curly y upon curly x equals to derivative of fx upon del x into this a sine as it is, a sine 2 pi mu into t. एंड अगर हम इसका डबल डेरिवेटिव करेंगे देन डेल स्क्वायर y अपॉन डेल एक्स स्क्वायर, एंड इसका भी क्या हो जाएगा डबल डेरिवेटिव, बिकॉज here it is here it will not change because we are differentiating it only with respect to x. Right? Let represent this by equation number 6. Now we need to substitute equation number 5 and equation number 6 in this equation number 1. Write down. Substitute equation 5 and 6 in equation number 1. Substitute equation 5 and 6 in equation number 1. You will get del, or you can also write this by del square f of x upon del x square. This quantity again is g of t. So write it as g of t into g of, and now represent this equation as equation number 6. Right? So del square y upon del x square is equals to del square f of x upon del x square into g of t equals to 1 upon u square. Right? And del square y upon del t square is this. So minus this 4 pi square mu square f of x into g of t. Right? This u1 by u square is 1 by u square, and del square y upon del t square is minus 4 pi square mu square f of x and g of t. So this g of t will cancel from both sides, left hand side and right hand side, and you will get del square f of x upon del x square equals to minus 4 pi square mu square upon u square f of x. Here from this equation you can see that this equation is independent of time. So we have separated out the variable. Right? And you also know that u is equals to mu into lambda. So substitute this value of u in this equation. You will get del square f of x upon del x square equals to minus 4 pi square mu square upon u square is mu square lambda square into f of x, right? This mu square will cancel from numerator and denominator. So what we have is del square f of x upon del x square equals to minus 4 pi square upon lambda square f of x. So now here the Edwin Schrodinger, he incorporated de Broglie idea. What was de Broglie idea? That all material particles possess dual nature, that is they behave like both particle as well as wave. So Schrodinger extended this idea to all material particles like electrons, protons, etc. And according to de Broglie equation, we know that lambda is equals to h upon mv. Lambda is equals to h upon mu according to de Broglie, and here u is the velocity of the electron. So and m is the mass of the particle. So from here you will substitute the value of lambda in this equation. Write down. Substitute the value of lambda. Right? You will get del square f of x divided by del x square equals to minus 4 pi square. Lambda square will be h square upon m square u square. Right? F of x. Right? 4 pi square as it is, lambda square will h square upon m square and u square. And you know that kinetic energy of a particle is given by half mu square. And what is this kinetic energy? This is total energy minus potential energy. Right? So half mu square is equals to E minus V, where E is the total energy and V is the potential energy. So mu square will become 2 into E minus V. Mu square will become 2 into double of E minus V. Now we will substitute this value of mu square in this equation, right? Substitute the value of mu square. Substitute the value of mu square. You will get del square f of x upon del x square equals to minus 4 pi square upon x square, 1 m as it is, and mu square is 2 into E minus V of f of x. This f of x, right? Or you can write down minus 8 pi square m upon h square E minus V of f of x. So this is the equation for one dimension, that is we are having only x coordinate. So if we extend this equation to 3-dimensional, then this f of x will be replaced by amplitude function represented by psi, and it will be a function of 3 coordinates x, y and z, right? Or for the convenience you can write it as psi. So extending this equation in 3 dimension, you will get, write down, you will get del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square equals to minus 8 pi square m upon h square e minus v of psi. Right? This is the equation which is known as Schrodinger wave equation. This equation is known as Schrodinger wave equation. Right? And what does Schrodinger wave equation represents? This equation represents the wave motion of particle in 3 dimensions.